Hello everyone, welcome to Easy Chemistry by Praveen. So today we are going to discuss about the new topic is called as a photoelectric effect. So what is meant by photoelectric effect? How can we understand the photoelectric effect? So photoelectric effect, once you observe the definition, the phenomenon of ejection of the electrons from the surface of metal when light of suitable frequency strikes is called as a photoelectric effect. So consider a one metal surface. I am taking the one metal surface here. I am taking. So when the metal surface some minimum one suitable frequency, that I am calling it as a h mu, or you can call it as a energy, some amount of energy of the light, this is called it as a light containing the energy. Whenever this light energy is passed over the metal surface, some electrons will come out from the metal surface. This phenomenon we are calling it as a photoelectric effect. Why we are causing photoelectric effect? In the sense, by using of the energy, by using of the light radiation, electrons are coming out. So that's why this is called photoelectric effect we are calling. You can see the second point, the electrons are ejected or called as a photoelectric effect. Due to the photoelectric effect, whatever the electrons are coming out, ejection is nothing but they are coming out from the metal surface. These electrons are called it as a photoelectrons we are calling. So due to the photoelectric effect, electrons are coming out, that is called a photoelectric effect. So you can see the third point, the photoelectric effect is readily exhibited by the alkali metals, potassium, rubidium, cesium. Why? Because alkali metals require the lower energy, low ionization potential. Why? Because they are mainly electropositive element. They are mainly electropositive element. Electropositive elements require the very low amount of energy. Why? Because the electrons, valency electrons are loosely bounded. So that's why minimum amount of energy is required to remove the electrons. So that's why photoelectric effect is readily exhibited by alkali metals it is exhibiting. So when the photon energy is more, automatically kinetic energy will be more. Electrons will come out, will be more. You can see, you can understand the some important points, important terms here. Work function, threshold energy. Work function or threshold energy. Work function is nothing but some work here you can see that some work has to be done. Here the minimum amount of energy is required for an electron to escape from the metal surface. For example, here I am considering the one metal surface. Here so many electrons will be there. So here some nuclear force of attractions will be there. In a metallic bond, nuclear force of attraction will be there. So to overcome the nuclear force of attractions, so here for example I am considering that this is the nucleus. Around the nucleus electrons are present here. So these electron, whatever the electrons is there, experience the nuclear force of attractions. That means some nuclear force of attraction is established between the nucleus and the electron. So here I am supplying some amount of energy, that I am calling it as a h mu naught we are calling. Of course I can call it as a frequency. Work function, so in terms of right now I am speaking with the work function, I am considering as a work function. Whenever I am supplying some photon energy, this energy helpful to overcome nuclear force of attractions. Nuclear force of attractions. So automatically electrons will come out. When electrons will come out, if I supply some minimum amount of energy for every element, there is some minimum amount of energy will be there, that we are calling it as a work function. If you supply some amount of energy, then only electrons will come out. If you supply below that, electrons will not come out. That is called as a work function we are calling. That is called it as a work function. Next one, in terms of the frequency, if you want to define the same concept, so here that is called as a threshold frequency, h mu naught we are calling. The threshold frequency is defined as minimum frequency. Just here difference, here we define in terms of the energy, here we are defining in terms of the frequency we are defined. The threshold frequency is nothing but is minimum frequency of incident radiation below which the photoelectric emission is not possible completely. So for example, energy, whatever the energy, which energy, work function theta. So here h mu naught. So if you are, it is the low, automatically frequency will be low. That means it is the minimum. Here also it will be minimum. We know that E directly proportional to the h mu naught. So just same concept here in terms of the frequency we are defining, in terms of the energy we are defining, threshold frequency. So same concept here. So here you are supplying the some amount of radiation of frequency we are supplying. Here I am telling about radiation of energy. Here some frequency we are supplying. That frequency helpful for the electrons to come out to overcome the nuclear force of attraction. That is called as a threshold frequency we are calling. Next one, threshold wavelength. What is mean by the threshold? What is mean by the threshold wavelength? So threshold wavelength, you can see that here we are talking about the maximum wavelength, not minimum. You have to understand here. Maximum wavelength of incident radiation needed to release electron from a given metal surfaces. So nothing but we know that mu naught is equal C by lambda naught. How we got the formula? We got the mu is equal C by lambda. Here lambda we are taking it as a threshold. That's why I kept it as a mu naught. So frequency, that's why I kept it as a mu naught. So here when the mu naught is low, lambda naught will be high, indirectly proportional. So lambda naught is nothing but the here threshold wavelength. Mu naught is nothing but threshold frequency. So the relation between the threshold frequency and the threshold wavelength is inversely proportion. One is increasing, one is decreasing. Okay. Next one, you can see some conditions will be there in the photoelectric effect. That conditions only, sometimes photoelectric effect is possible, sometimes photoelectric effect is not at all possible. So for example, I am considering the one metal surface I am considering. On the metal surfaces, if you see the conditions of the metal surface, so here incident radiation I am defining as a h mu. So this is called as a incident, this is called as a incident radiation. That means whatever the energy we are supplying, whatever the frequency we are supplying, that I am indicating with the h mu we are indicating. H mu naught, whenever you are using the naught, nothing but here threshold frequency. You can threshold frequency, in place of threshold frequency you can go with the work function also. So here kinetic energy, we know that kinetic energy, this is nothing but work function. Work function. This type of terms we have to understand. So for example, I am supplying the some amount of energy, that is called incident radiation, h mu or E, whatever it may be. If I define in case of energy, I will go with the E. If I define in terms of the frequency, I will go with the h mu. So whenever I am supplying the h mu, but here the condition is h mu, whatever the supplying h mu is less than, that means work function is greater. If you understand, for example here to observe the photoelectric effect, that means electron should come outside, I have to supply the 1 electron volt, nothing but work function is should be equal to 1 electron volt here. But h mu, whatever the h mu I am supplying, 20 electron volt only I am supplying here. So electrons will not come out from the metal surface. If the electrons to come out from the metal surface, I have to supply 1 electron volt. But here 20 electrons volt you are supplying. That means work function is greater than the incident radiation. Work function is greater than the whatever the incident frequency, incident energy. So then no photoelectric effect. No photoelectric effect. No photoelectric effect. Why? Because energy is less. We are not supplying the threshold energy. We are not supplying the threshold frequency. We are not supplying the threshold wavelength. So condition number 2. So here I am considering the another metal surface. So here I am supplying the some incident radiation, that is called as a h mu. Here, for example, 100 electron volt. To understand better, I am taking 100 electron volt is the work function. So whatever the frequency, whatever the energy I am giving incident radiation, that is equal to 100 electron volt. That means some energy I am supplying, that energy is equal to the work function. So automatically what will happen? Photoelectric effect is observed. Why? Because same amount, whatever the energy is required for the electrons to come out, that energy I am supplying. So when h mu is equal to the theta, or h mu is equal h mu naught, frequency, in terms of frequency, in terms of the energy, whatever you can see that. Otherwise you can go with the incident radiation or incident frequency is equal to the threshold frequency or the work function. Photoelectric effect is possible. So photoelectric effect is possible. So third case you can see. So here I am considering the one metal surface. I am considering here the one metal surface. Here what are the conditions will be there? This is the third conditions. So here on the metal surface, h mu, whatever the incident radiation is there, incident radiation is greater than the work function. So that means what? 100 electron volt is required, for example, work function. But here I am giving the 200 electron volt. Then photoelectrical effect is observed. So here electrons will come out, automatically they are having the kinetic energy. We know that h mu is equal h mu naught plus kinetic energy. I am giving the 200 electron volt energy I am giving. So but I took electrons to come out from the metal surface, only 1 electron volt energy is required. So rest of the energy converted into the kinetic energy. So that's why they are having here kinetic energy will be more. Kinetic energy is not equal to 0. Second case, kinetic energy will be equal to 0, it will be there. You can see some important points here. So from this you can write h mu is equal h mu naught plus kV. So here h mu is equal h mu naught plus of mv square. Electrons you can carry it as a v. So you can write another way also. H mu is equal mu in the nothing but c by lambda. Here h mu naught is right c by lambda naught, half mv square, half m electron will come now mv square. Like this you can write. Okay. Next one you can see important point. Photoelectric effect is an evidence of particle nature of the light. It is not giving the evidence of the wave nature. Third point we can understand better. We can understand. So next one you can see that kinetic energy of this electron increases with increase in frequency of the light. Kinetic energy. So for example, if you observe the graph, if you observe kinetic energy versus frequency, when the frequency is increasing, kinetic energy is also increasing. You can see that h mu is equal h mu naught plus kinetic energy. So for example, h mu naught only 20 electron volt we want, but here we are supplying the 200 electron volt. That means what? Frequency, incident radiation or incident frequency is more. So automatically rest energy is converted into the kinetic energy. Okay, 180 kilo, 1 electron volt. This means inversion, directly proportional relationship is there. So some cases h mu is equal to the h mu naught. Incident radiation frequency is equal to the threshold frequency. That time kinetic energy is 0. When V is equal V naught, incident frequency is equal to the threshold frequency, that is kinetic energy will be 0. There is third point. There is no time lag between, that means time gap between the striking of the light beam and the ejection of the electron. So for example, I am taking the one metal surface I am taking. one metal surface I am taking here. So here whenever I am taking the some metal surface, I am supplying the some amount of energy of incident radiation or incident photons I am supplying. So whenever the incident photon we are supplying, so within a fraction of seconds only electrons will come out. There is no time gap. So for example, this is also evidence of the particle nature. So for example, if you consider light is a wave nature, we are considering it is as a wave nature. To come striking of the wave nature containing the light to come out from the metal surface, it will take some time it will take. But here it is not taking that some much of time. So that's why it is considered as a particle nature. It is an evidence of the particle nature. Next point, you can see that the number of electron ejected, this means ejected electrons, photoelectrons, is directly proportional to the intensity of the light. So intensity of the light is nothing but the number of photons per unit area. So for example, here 2 photons. For example, here 1 unit area, more photons will come. Automatically electrons will come out. More electrons will come out. That means intensity or brightness of the light. Next one, kinetic energy of the photoelectron varies 0 to maximum depends upon the frequency. We know that h mu is increasing, kinetic energy is also increasing. Just now we have seen kinetic energy, it will be like a increase only. But if you draw a graph, kinetic energy versus intensity, intensity is nothing but the number of photons per unit area. There is no change in the kinetic energy. Kinetic energy will increases with increasing of the frequency only, it will increases. Okay, this is about the kinetic energy. This is about the some important points of the photoelectric effect. Now you can see the stopping potential. What is mean by stopping potential? Stopping potential is nothing but just a reverse of the photoelectric effect. You can see that the stopping potential is defined as potential required or energy is required. Stopping potential is required to stop the ejection of the electrons from a metal surface when incident beam of energy is greater than the work potential. So generally, that means just you have to understand the minimum amount of energy we have to supply, or we have to give some potential we have to give to stop the ejection of electron, to stop the photoelectric effect. That is we are calling it as a stopping potential. The potential is required to stop the photoelectric effect, that is called stopping potential. So generally, photoelectric effect, if you observe the photoelectric effect, so here 2 electrodes, so here metal will be there, here collector will be there, photoelectron collector. This is connected to the positive terminal, this is connected to the negative terminal. So h mu is greater than the frequency. That time what will happen? Electrons will come out. This is negative, no? Electrons will come out. Generally, this is photoelectric effect. But we have to do here reverse. Just we have to do here reverse. We have to do here. So here collector will be there. So metal surfaces will be there. These two are connected to the voltage. But here connected. Whatever the collector is there, no, here we have to connect it to the negative terminal. Here before we are connected to the positive terminal, so we are connected to the negative terminal. This we connected to the positive terminal, connected to the positive terminals. So here whenever you are connected to the positive terminal, so electrons will not come out. This means whatever the frequency will be there, no, that will be like a minimum will be there, nothing but stopping, that is called stopping potential. Just reverse. So potential we are supplying, that will not helpful for the photoelectric effect, that will stop the photoelectrical effect. That means kinetic energy will be like a 0. How kinetic energy is converted here in this case? So kinetic energy is converted into electrostatic potential energy. It is connected electrostatic potential energy. Kinetic energy is 0. So we know that half mv square, kinetic energy is nothing but half mv square, is converted into the electrostatic potential energy. So stopping potential we denoted with the V naught electrons. So V naught into E. So from this we can write that H mu, generally we know that H mu is equal H mu naught plus kinetic energy. So from this we can write H mu is nothing but C by lambda. H mu naught in place you can write stopping potential. H mu naught is equal lambda naught. Kinetic energy, in place of kinetic energy you can write E V naught. E is nothing but electron. Stopping potential. V naught is not V naught, E V naught is nothing but stopping potential. So this is about the photoelectric effect. Next session I will discuss about the previous NEET and IIT numericals we will discuss.